Hi guys, let us solve traveling salesman problem using branch and bound algorithm. Problem statement of traveling salesman problem. Input a set of cities and the distance between every pair of cities. The goal is to find the shortest possible route that visits every city only once and returns to the starting point. That is, a set of cities are given as nodes in a graph. Distance between every pair of cities are given as edges between the nodes in a graph. The traveling salesman problem is given in the form of graph as shown in the figure. Here the cities are A, B, C, D. We assume that traveling salesman begins his journey from the starting point A, because as per the alphabetical order we assume he is starting the journey from city A. He has to visit all the cities only once, that is A, B, C, D, and he has to come back to the city A. In that way, we want to find the shortest possible route for this travel. The first step in this solution is to form the adjacency matrix for the given graph. The graph contains four nodes A, B, C, D, and so the matrix size will be 4 by 4, and row and columns are labeled as in the form of A, B, C, D as shown in the diagram. Now you find that is there any direct edge between the nodes. For example, A to A. So there is no edge for A to A. So it is represented as infinity. For A to B. So A to B there is a direct edge with the weight of 4. So you represent it as 4 here. Like that for A to C there is a direct edge with the weight of 12. You represent it here. Like that for A to D also there is a direct edge. You represent it as 7. And B to A you see that there is a direct edge with the weight of 5. And B to B it is infinity. And B to C there is no direct edge between B to C, so it is represented as infinity. For B to D there is a direct edge, you represent it as 18 because weight is given as 18. So like that we have to fill the adjacency matrix. Now you take the adjacency matrix of the given graph as a reference matrix and apply row reduction. What is meant by row reduction? If there is a 0 in the row already, then no reduction is required. Otherwise, subtract the minimum element in that row from all the elements of that row. So now this is the adjacency matrix. You refer the first row. So there is no 0 in the first row. So we have to apply row reduction. So what is the minimum element here? 4. So you subtract 4 from all the elements in that row only. So we have to listen carefully. This is applied only for this row. So if you subtract by 4, this will become 0, 12 minus 4, 8, and 7 minus 4, 3. So like that for second row, is there any 0? So there is no 0 in the row. So we have to apply row reduction. So what is the minimum element in that row? 5. So subtract 5 from the elements of the second row. So this will become 0. Then infinity will be as it is, and 18 minus 5, 13. And third row there is no 0. Minimum element is 6. So subtract 6 from the elements of the third row. So 11 minus 6, 5, and infinity will be as it is. This will become 0. And fourth row there is no 0 already. So we have to apply row reduction. So what is the minimum element? 2. So subtract 2 from all the elements. So 8, 0, 1 and infinity. So this is what we call it as row reduction. To find the total row reduction value, we have to add the absolute values of these numbers. That means we are adding only 4 plus 5 plus 6 plus 2 without the minus sign. So what is the total value? You are getting 17. Take the matrix after row reduction as reference and apply column reduction. If there is a 0 in the column already, then no column reduction required. Otherwise, subtract a minimum element in that particular column from all the elements in that column. For example, in this matrix, the first column contains 0, so no column reduction is required. You copy the elements as it is. And the second column, it also contains 0, so no column reduction required. You copy the element as it is. But for third column, there is no 0 here. So what is the minimum element? 1. So subtract 1 from all the elements of this particular column. So 8 minus 1, 7. Infinities will be as it is. 1 minus 1, 0. For fourth column, there is a 0 already in that column. So there is no column reduction required. You copy the elements as it is. So now, what is the total column reduction value? So first column, no reduction, 0. Second column, no reduction, 0. For third column, we have subtracted by 1. So you take the absolute value 1. Fourth column, no reduction, you take it as 0. So total column reduction is equal to 1. Sum of row and column reduction, we have already calculated row reduction value 17, column reduction value 1, 17 plus 1, 18. Starting node is A and this lower bound value is sum of row reduction and column reduction value. So sum of row reduction and column reduction value is 18. That the value you are keeping it as lower bound for the starting node. And this matrix we obtained after row reduction and column reduction, and this matrix is going to be used as a reference for the next calculation. So what is the next calculation? A to B. So here the distance of A to B in this matrix, you refer the entry here 0, that is what given here, and set the row A and column B to infinity. So in this matrix, row A and column B make it as infinity. That is what done here in this matrix, and make B to A as infinity. So refer the entry here B to A as infinity, and all other elements we are copying it from this matrix. Now in this matrix you apply row reduction and column reduction. For the first row all the values are infinity, so no row reduction required. For the second row there is no 0 and 13 is the minimum value, so we have to subtract by 13 in the second row. For the third row there is a 0, so no row reduction applied, you copy it as it is. And the fourth row there is a 0, so there is no row reduction required. So we have to subtract only 13 from the second row. So in that way this element will become 0. But what about column reduction? So the first column there is no 0, but what is the minimum element? 5. So subtract 5 from the first column. So this will become 0, and 8 minus 5, 3. So second column all the values are infinity, so no column reduction required. Third column there is a 0 already, so no column reduction. And fourth row there is a 0 already, no column reduction. So the total reduction is absolute value of this is 13 plus 5, that is 18. So what is the cost for the new node A to B is cost of 1. So what is the cost of 1? 18 we already calculated. And what is the total reduction for the recent calculation? Again that is also 18 plus and what is the value of distance of A to B? So that we have taken from this matrix, that is 0, so the value is 36. So 36 is the value for this node. The next calculation is A to C. The matrix obtained after first row reduction and column reduction is used as a reference in this calculation also. So this matrix will be used as reference. Now find the distance of A to C in this matrix. The entry is 7, so take the value here, and in this matrix make the row A and column C as infinity. So that is what we have done here in this matrix. and make C2A as infinity. So refer the entry C2A, you are making it as infinity, and other elements you copy it from this matrix. Now we have to apply row reduction and column reduction for this new matrix. But you refer the first row, all the values are infinity, so no row reduction required. And second row already contains a 0. Third row also contains a 0. And fourth row also contains a 0. So no row reduction required at all. And first column contains a 0. Second column contains a 0. Third column all the values are infinity. So no column reduction required. And fourth column also already contains a 0. So no column reduction required. So for this matrix, the total reduction value is 0. So now you calculate the cost for this node. So cost of 1. So what is the cost of 1? 18, which we already calculated. So what is the total reduction for this matrix? It is 0. And what is the distance of A to C, which you already taken? 7. So you add these values, 25. So the 25 is the value for this A to C option. The next calculation is A to D. Here also we are going to use the matrix obtained after first row reduction and column reduction as a reference. So this matrix is used as a reference. And what is the entry for A to D? So refer A to D here. The distance is 3. You copy the value here. And in this matrix, set the row A and column D as infinity. That is what done here. And make D to A as infinity. So other elements you copy it from this matrix. So this is the new matrix, we got it after making these changes. Now you apply row reduction and column reduction for this matrix. So when you talk about row reduction here, the first row all the values are infinity, so no row reduction required. Second row already contains a 0, but the third row contains value 5, so we have to subtract by 5 because the minimum value is 5. So when you subtract by 5, this element will become 0, and fourth row already contains a 0. And column reduction, the first column contains a 0, second column contains a 0, third column contains a 0, and fourth column all the values are infinity, so no column reduction required here. So what is the total reduction value? So we have to take the absolute value of this, that is 5. So now the calculation for the node is cost of 1. So what is the cost of 1? 18, plus what is the total reduction for this matrix? 5, plus what is the distance of A to D, which you already taken? 3. So add all these values, you will get 26. 26 is the value for this node A to D. We started with the node A and we have explored all the options A to B, A to C, A to D. Out of these three, the lowest value is here for the option A to C. Now, after A to C, what are the other two nodes left? B and D. So now I am going to do calculation for A to C and C to B. Now you take the value distance of C to B from this matrix. So you have to note it down very carefully. What is this matrix? This matrix is the one we got it after row reduction and column reduction when we have done calculation for A to C. So you have to refer the calculation of this A to C. From this place you have to take the matrix as a reference for the next node. So now we have taken the value of distance C to B. You refer C to B, it is a infinity. C to B is infinity, you copy it here. And set the row C and column B to infinity. So in this matrix, row C and column B as infinity. So that is what we got it here. And make B to A as infinity. So we have made B to A as infinity here. And other elements you copy it from this matrix. So this is the new matrix, we got it. Now we have to apply row reduction and column reduction for this matrix. So you refer this first row contains all the values are infinity, so no row reduction required. But for the second row, there is a value 13 here. So we have to subtract by 13 to make it as 0. Third row contains only infinity, no row reduction. And fourth row contains the value 8. So you subtract by 8. Isn't it or not? So you got a 0 here, and column reduction, there is no column reduction required for this matrix because first column contains a 0, second and third column full of infinity, and fourth column already contains a 0. So the total reduction value is 13 plus 8, 21. Now the cost for this node is cost of 3. So we have to use this value 25 plus the total reduction for this matrix is 21, and the distance value is infinity, and total value will become infinity. So infinity is the value for this option A to C and C to B. The next calculation is A to C and C to D. For this also, this matrix which we obtained in the calculation of A to C after row reduction and column reduction is used as reference. Now take the distance of C to D. So in this matrix C to D, the entry is 0. So copy the value here. And in this matrix, make the row C and column D as infinity. So that is the matrix, you got it here. And D to A as infinity. So this entry, we made it as infinity. And other values, you copy it from this matrix to this new matrix. Now, for this new matrix, we have to apply row reduction and column reduction. So you refer this matrix. So the first row, all the elements are infinity, so no row reduction required. Second row already contains a 0. Third row, all the values are infinity, and fourth row already contains a 0, so no row reduction required. And column reduction, first column contains a 0, second column contains a 0, and third and fourth column all are infinity. So no row reduction and column reduction. So total reduction value is 0. So now what is the cost for this node? Cost of 3. So you take this 25 plus what is the total reduction value here? 0. That is for this matrix. And what is the distance we copied? 0. So by adding all these things, you will get 25. So the 25 is the value for this option A to C and C to D. Now we compare these two values. This is the minimum one. So we are going to expand this node. So what is the path? A to C and C to D. So what is the only one node left? B. So now I am going to do calculation for A to C, C to D and D to B. Now this matrix, what we got it after row reduction and column reduction in the calculation of A to C and C to D, this matrix have to be used as reference here. That is very important point. Okay, so in this calculation A to C and C to D, the matrix you got after row reduction and column reduction is going to be used as reference matrix here. And take the distance of D to B in this matrix. D to B is 0. And in this matrix, you make a row D and column B as infinity. So this is the matrix, you got it after making row D and column B as infinity. And also B to A, the entry B to A also you make it as infinity. So now this is the matrix we got it after making the changes, which contains all the values are infinity. So no row reduction and column reduction required. That means the total reduction for this matrix is 0. So now you apply this calculation, cost of 6. So what is the cost of 6? 25. And total reduction for this matrix is 0. And the distance is also 0. So what is the value? 25. The 25 is the value for A to C, C to D and D to B. So the final solution is A to C, C to D, D to B and B to A, and total cost is equal to 25 units. Now the exercise problem, apply branch and bound algorithm to solve the traveling salesman problem. So you can apply branch and bound algorithm for this given graph.